Hey guys, my name is Erin Parker. I'm a graduate research assistant with Athlete Engineering, and this is Simrall Engineering Building, so let's go see our wearable technology lab. So I'm from Powder Springs, Georgia. I came to Mississippi State because I knew I wanted to be involved with research with wearable technology, and so I wanted a school where I could study both fashion design and computer engineering. So I graduated with both of those bachelor's degrees in May, and now I am studying industrial engineering here at State, focusing on manufacturing and trying to take this research a little bit further, trying to see how you can actually make these devices the actual product. I've been here 6 years, going on 7, because that double major took me 5 years in my undergrad, and then now I'll be here for 2 years with my master's. Athlete Engineering is a multidisciplinary research group on campus. We work with strength and conditioning coaches, being able to help them organize and collect all of their data. We work with wearable technology development, creating our sock prototypes, like the ones that are in front of me, and also just with wearable technology validation. So we have our motion capture lab, and we're able to use that gold standard in motion capture to see how accurate these wearable devices are. So my favorite part about athlete engineering is that there are so many different types of people that are working with it. We have all kinds of engineering disciplines, fashion design, kinesiology, sociology, all the student athletes that you get to work with, and also the strength and conditioning coaches. It's very, very helpful, I think, as a student to be able to see the number of different avenues that you can take such one simple concept, something as, just simple as athletic performance. So my specific research interests lie with the wearable technology itself, how it's produced, how you can make it both accurate and comfortable. So with the sock project that I'm working on, we're trying to make it an actual commercialized product. And so I deal with a lot of manufacturers and vendors trying to see how we can integrate electronic components into fabrics instead of them being two separate things. So these sock prototypes use stretch sensor technology. So basically what that means is the electrical properties of those sensors change when the mechanical properties change. So if you stretch them, if you press on them, you're going to be able to see an output from that is changed. And that output is actually linear, so if you stretch it 1 inch, it's going to change the electrical output by 1 time. If you stretch it 2 inches, it'll be ×2, basically is kind of how that works. And so these sensors, when you place them around the ankle, like we have done with our prototype, you are able to use that linearity of the sensors to find ankle movements and ankle angles. And what we have done with the paper series we've written is taken these socks and hooked them up to motion capture as well, and been able to see that they're about like 96% accurate to what the motion capture is saying, which is pretty good for me. One day, get my PhD, continue this research, maybe go a little bit deeper into actually the textiles, e-textiles part of it. It's what they call electronic textiles. Just research that a bit more and really become an expert in that field. Because I think one day my goal would be that I really like teaching, and I would love to be able to share like what I know with the next generation of people who are going to be designing these products. But also just to continue working in research. I really like research. I think I'm a true engineer at heart, and I just want to make stuff for the fun of making stuff. If you have had an injury and you're trying to recover and you're not quite sure how well you're doing, wearing something like this and being able to track data day after day after day is going to show you if you're improving and how much you're improving. And if maybe you're not improving the way you need to be, your doctor can see that and change your routine and your exercises that you're doing. So I think something like this is going to be really good for improving quality of life for athletes, and also rehabilitation patience. The biggest challenge with these socks really has been how do you integrate electronic components into textiles. I think in the grant proposal they wrote for these socks, they had one line that said the sensors will be in socks, and that was the entirety of the thought that was put into it beforehand. But I cannot blame them at all. It's such a hard problem, and there's a reason that smart socks are a market that don't entirely exist. There are a few things out there, but they're not really completely fleshed out. But our team is really dedicated to figuring it out, and I'm just excited to see what we can do with it. At this university, everyone wants the university to succeed as a whole. There's not a lot of that interdepartmental competition going on. I think that's really what sets us apart as we work together so well.